So here we're going to go over the power of a product property. So remember, a product is factors that are being multiplied. So here we're looking at a base that has multiple factors. So the factors are 3 and k. Remember, factors are individual numbers that are being multiplied. So in this case, we have 3 is one factor and k is the other factor. So if I was to write this in expanded form, I would take the base and I would write the base 4 times with multiplication in between. So I would get this: 3k times 3k times 3k times 3k. So now if I was to take this and I was to write it in simplified exponential form, I would go ahead and count the number of 3's I'm multiplying, which would be 4. So I would do 3 to the 4th power. And then I would go ahead and I would count the number of k's, which would be 4. So k is being multiplied 4 times. So that means k is to the 4th power, which means I have 3 to the 4th power and k to the 4th power. I can simplify it further by actually doing 3 to the 4th power, which would give me 81 k to the 4th power. So what happened with that 4? Well, the 4 got passed on to the 3 and it got passed on to the k. So let's go ahead and simplify what the power of a product property is. So basically what it's saying is that when our base has multiple factors, and it has to be multiplication or its inverse, which is division, that exponent gets distributed, basically. That each individual factor in the base receives that exponent. So if you were to go ahead and say this in words, if the base of an exponential expression is a product, and again, or its inverse, a quotient, you distribute the exponent to each factor of the base. So let's go ahead and do some practice problems with that. So here we have one that looks very simple, just like we had in the actual product property, power of a product property. Okay, so that means our 2 is going to go to the 3. So we get 3 squared. And the 2 goes to the x, so times the x squared. And now we just simplify what we can. So we can do 3 squared. So 3 squared is 3 times 3, which is 9. And we can't square x because we don't know what x is, so we simply write it as x squared. Now, sometimes we have to combine properties. So let's go ahead and look how this second problem combines some properties. So I see I have 2 factors here. And let me go ahead and highlight it so just to emphasize. So here we have 5 is one of our factors. And the second factor is m to the 3rd. So those are the 2 things being multiplied. The first thing I'm going to do is I'm going to raise 5 to the 4th power. So I'm going to rewrite this as 5, and I'm going to raise it to the 4th power. And then I'm going to multiply it by m to the 3rd, which is my second base. M to the 3rd. And then I'm going to raise m to the 3rd to the 4th power. Okay, so now I'm going to go ahead and do what I have to do with those exponents. So I'm going to simplify the exponent part. So now, can I do 5 to the 4th power? Yes. So if I do 5 times 5 is 25. 25 times 5 is 125. 125 times 5 is 625. Okay, now I'm going to do m cubed, or m to the 3rd, to the 4th power. So remember, we talked about we sometimes have to use other properties. So this property, remember, is the power of a power property. So remember that one says that when we have an exponential expression as our base raised to a power, we multiply the exponents. So that means we're going to keep our base, which is m, and we're going to multiply the exponents 3 and 4. So 3 times 4 would make 12. So our exponent is 12 for the base m. So our final exponential expression would be 625 times m to the 12th. Okay, so here is where we go ahead and we use the power of a product property for a quotient. And the reason it works for quotients is because, remember, product means multiply, quotient is for division, and they are inverse operations, which means they're basically opposite sides of the same coin. So it works the same way. Whenever we have an exponent and our base is a quotient, we distribute to both parts. So we're going to go ahead and we're going to take our numerator, and it's going to be raised to the 5th power. And then we're going to take our denominator, k cubed, and we are going to raise it to the 5th power. And now we're going to do whatever the math says in the numerator and in the denominator. So we're going to do 2 to the 5th power. So we multiply 2 times itself 5 times. So 2 times 2, 4, 8, 16, 32. Since we don't know what k is, remember the only thing here we can do is we can apply that property that says that an exponential expression raised to a power of a power means we multiply the exponents. So I keep the base of k, and then I go ahead and multiply the exponents 3 times 5, and that gives me the exponent of 15. So my final answer is 32 over k raised to the 15th power.